Okay, we're going to look at problem number 25. So problem number 25, this is part 2. Part 1, we looked at how to find displacement and velocity. Part 2, we're going to look and see how we can find time. So that's going to be our missing piece. Okay, Simpson drives his car with an average velocity of 85 kilometers per hour eastward. How long will it take for him to drive 560 kilometers on a perfectly straight highway? So this perfectly straight is important because we know that distance traveled and displacement are different, but if it's completely straight, they're the same. So this perfectly straight is important because it tells us that this is the displacement. So we know that the velocity is going to be equal to 85 kilometers per hour. Our displacement, delta x, is going to be equal to 560 kilometers. And we're trying to find delta t. So we know, or we're given, velocity and displacement, and we're trying to find delta t, the time. Okay, our equation. So we know that velocity is equal to delta x over delta t. We want to solve for delta t. So when we have something like this, we can switch their positions, but we can just prove it using math. So we multiply both sides by delta t to get rid of it. So we get delta x is equal to v times delta t, and we're trying to find delta t, so let's rewrite this. We're going to divide this side by v and this side by v to get rid of that. So we get delta t is equal to delta x over v. Or we can just say that v and t switch places. V and t switch places. So lastly, our delta t is going to be our delta x, which is 560 kilometers, divided by 85 kilometers per hour. So usually we have units in meters per second. Here it's kilometers per hour. So kilometers is going to go away. We're getting an answer in hours. So we do 560 divided by 85. We should get 6.588. So we're going to round that to 6.59. Hours. So just to review, we have displacement, velocity, and time. These are all the possible combinations that you can solve for.